All right, we're ready at the start time, 2 o'clock Eastern Standard Time. So I'm gonna go ahead and begin. Get some housekeeping out of the way while we allow some more people to join. First off, good afternoon. I am Jason Thomas. I'm a project engineer here at America Makes, and I'll be your host for today's America Makes TRX webinar series. Just a little background on the TRX webinar series before I introduce our speaker. As America Makes continues its mission to expand and accelerate the footprint of additive manufacturing and 3D printing, this medium called the America Makes Technical Review and Exchange webinar series was created. By creating this platform, it allows the additive manufacturing and 3D printing community to come together and share knowledge and experience with the broader community. If you or your team are interested in presenting during the TRX webinar series, there will be a link to complete the request form at the end of our series today, or you can contact the America Makes TRX webinar series administrator, myself, Jason Thomas, directly. A few important notes before we do kick off the series. At the end of the presentation, there will be an opportunity for a question and answer session. So if during the presentation you have any questions, please submit them in the Q&A space on your WebEx screen, and I'll ask it during the Q&A session. We'll try and get all of your questions answered. Today's webinar is on demonstrating an AM data management approach for America Makes. So a little background on this. I was really excited to see this come in. We had an open project call in 2021. We've been having open project calls for the last 3 years and hope to continue to do so. We had a topic on data management, which is becoming a very important thing as we move forward. And Mike put a proposal in, and he was chosen for the award. I was very happy to see that, and I was excited to see how the project went. So without further ado, it is my pleasure to introduce Mike Vasquez. Dr. Mike Vasquez is a 3D printing expert specializing in pushing the boundaries of advanced 3D printing technology. He is the founder and CEO of 3 Degrees, a Chicago-based consulting company focused on helping organizations maximize their investment in technology. Over the past decade, he has worked side by side with some of the top machine manufacturers, material producers, and end users in the industry, consulting with them to identify novel applications, test new materials, and develop frameworks to maximize R&D efficiency and boost return on investment. Based on insights gleaned from the consulting, Mike has spun out 2 additional organizations. First, a software company called TraceAM, with the mission to help manufacturers organize and analyze their 3D printing digital data. In the last year, they have worked with customers such as Air Force Research Lab, Renishaw, Ohio State University, and Fabersonic. The second organization, AMX, or Advanced Manufacturing Experience, was created by Mike to offer an on-ramp for new workers from disadvantaged regions looking to enter the field of advanced manufacturing, a voluntary effort designed to give back to industry and community. The pilot course was run in the west side of Chicago and with support from America Makes and West Side Forward. In 2022, AMX is hoping to secure funding to branch out to multiple cities and regions. Mike completed his PhD in additive manufacturing at Loughborough University and received both his bachelor's and master's from MIT in material science and engineering. Mike is regularly asked to speak as an expert on the topic of 3D printing and has given talks at South by Southwest, the National Association of Attorneys General annual meeting, and numerous other industry conferences. Mike is the host of 3 Degrees Discussions, a weekly podcast where he speaks with innovators, entrepreneurs, and leaders in the 3D printing industry, which I have seen a couple of, and they are very good. So thank you for that, Mike. Currently, the show has over 86 episodes, including interviews from leaders at NASA, Ford, and Boeing. So, Mike, I'll now turn it over to you and your team.
All right. Thank you so much, Jason, and appreciate everyone taking some time out of their Wednesday today to chat about 3D printing and specifically kind of data management around the technology. So, let's see. I'm not able to share right now. I should have checked this beforehand, but let me see if I can get this going right now. But anyways, I'm going to have a couple of different topics for discussion today. One is I'll share some slides on the technology, on what we've done with with the technology, with America Makes specifically in and around data management. And kind of the other piece is what I want to do is actually give a demo of the TraceAM software that we've developed and how we can actually engage users in the additive manufacturing world, and specifically in kind of the America Makes community, to help them better understand kind of data management, implement it in their own organization, and also really leverage what is best for the community in and around America Makes, with all the different projects that have gone on over the last 10 years. And so it's kind of fitting over that next week is MMX and kind of the 10-year anniversary. So one of the things that we'll be doing is trying to share with the community some of our learnings, to say, hey, like, there's been awesome, great work that's been going on in the last 10 years. I think one of the things that we will continue to do and want to see from a membership perspective is, like, how do we get access to some of that data and some of those learnings? And so Trace is one of the solutions that we developed to do that. So Jason, I had a issue come up with my WebEx, so I'm had to enable it to share. So I'm going to just drop out for 30 seconds, come back in, and I'll be able to share my screen. So give me a second, and I'll be right back. So apologies for that little technical glitch here, but I will be back shortly once I reopen this. So,
all right, thanks, Mike. We'll be waiting for you.
Yeah.
All right, so I'll go ahead and fill in here for a couple of minutes for Mike here. Just a brief overview of the presentation today. So currently, when users log into the America Makes Digital Storefront, they see a text-heavy dashboard listing historical projects. And with project data that is stored in a variety of formats, we have a lot of our things in Word, Excel, and PDF at this time. Although this is perfectly suitable for accessing certain types of data, like final reports, TRX, and PowerPoint presentation, it makes it very difficult for members to see comparative data or analyze any of that data. So 3 Degrees worked with America Makes and some other team members to build a functional proof of concept database utilizing TraceAM software. So I see Mike's back on. I'm going to go ahead and pass this over to Mike. Hey, Mike, I'm not able to hear you. Oh, I think you're muted.
All right. So sorry about that.
That's okay.
After 2 years of doing this, I should be better at this. But appreciate the patience with me, everyone. As Jason mentioned, my name is Mike Vasquez. I run a company out in Chicago called 3 Degrees. And so what we're going to be doing today for the webinar is talking a little bit about the work we've been doing on mainly the data management front with TraceAM. We'll talk a little bit about what Jason mentioned, as well as some of the workforce development efforts that we've been doing. So just a little bit of background. I started the company about 12 years ago, really as a kind of an answer to some of the industry needs that we saw as the additive space was evolving. Is like, how do you kind of transition the technology from purely prototyping into production? And as you know, for a lot of you on the call today who have gone through that process and looked at thinking through, okay, how do we scale this technology? What do we need to do in terms of setting up a facility, qualifying materials, developing data sets, and kind of getting products into market? That's where I kind of live on a day-to-day basis, and helping a variety of industries and companies in those industries look at that challenge. And so over the last 10 years, we've learned a lot. One of the things that we got frustrated about specifically was every time we'd go into a company, whether it was medical, whether it was aerospace, automotive, people would spend millions of dollars on equipment and lots of titanium and making sure their production facility was safe if they're using metal. And then you get into printing, you're producing parts, you got a kind of baseline, and then you quickly realize that there's a lot of data, there's a lot of information that's coming around. Every time you do a build, every time you turn on the lights in the facility, you've got materials information, you've got production process information, the technician, like when was your last maintenance. All of this data is kind of floating around on a day-to-day basis. And it was really kind of overwhelming to look at the amount it was taking up in terms of engineers' time to maintain that and put it into data systems that were somewhat antiquated. So most companies, we did this listening tour about probably 5 years ago. I went around to 100 different companies. I kind of went in and said, hey, like, where are you at your additive adoption phase? And then kind of the second and third and fourth question was really about how are you managing your data? Like, how are you keeping track of, if you're going through qualification, the tensile specimens that you might be building or the density cubes that you might be putting into your machine on a day-to-day basis? Do you know what build those go to? Do you know what material lot number those were traced back to? And for the most part, they could answer yes, but it's going to take me a while. And the reason for that was 96 companies out of those 100 companies were using primitive tools like Microsoft Excel. And so that's when we decided to really jump into the world of data management and build our trace software, which I'll talk more about in the next few slides. And so that was really kind of a spin-off of the consulting, is saying, how do we see this problem across industries? We see this problem not getting any simpler as the technology matures. And so how are we going to help solve that? A couple other things that we're involved in, as Jason mentioned, we do a voluntary program called AMX here on the west side of Chicago. I actually just got done with our second cohort of that. Things I'm passionate about, as well as like how do we continue to sustain manufacturing in the U.S. and specifically giving people an on-ramp to this cool technology. I'm sure kind of all of you who are listening, no matter what company I talk to, they could always use better people and more people. And so I think exposing organizations, people specifically who may not be aware of additive manufacturing to the industry is something we're passionate about as well. So let's get into the kind of meat and potatoes of what we're going to talk about, and specifically that's our TraceAM data management software and how we want to work with America Makes to help kind of make better use of data that's been generated into 3D printing, and more specifically, kind of all the projects that have been done over the last 10 years. How do we make some of that information more accessible, and think in the future of kind of from a 30,000 foot perspective, how do we make sure that organizations are enabled with the right information to develop products, right? Like we're not in the business of just developing test coupons and a material data sheet for a material. We want to build parts that go on planes, that go into people's bodies. And it's really the design that's going to enable new technologies and new products. But there's a lot of testing and validation that goes into that. And so how do we kind of do qualification, do kind of this data generation in a smart way that can be shared across industries? So our TraceAM software was developed kind of by us, who kind of industry users, with a lot of industry feedback to really solve the challenge of kind of what do you do with all the information that primarily lives in Microsoft Excel or SharePoint or Dropbox that you have in all these different locations across the organization, and make it more streamlined, make it so that when Joe, who's your lead additive engineer, takes a 2-month vacation or goes out on leave, like that, you don't spend 2 weeks just trying to track down what they're doing, or if something goes wrong, you need to kind of more quickly be able to ramp up kind of recipes and find root cause if there's a problem. So the idea was like, how do we kind of enable better research, production, and technology improvements by kind of giving engineers, users a better data management system to do that. So our thought was, okay, how do we take the AM workflow that is pretty unique across a lot of different technologies, right? You got FDM, you've got SLA, you've got metal powder bed. But there's a lot of fundamental things and steps that are consistent across those. How do we streamline that a little bit and make use of what consistencies there are to store and track that data? And so we do that by kind of tracking every step of the process and making sure that you both have a kind of recipe that someone can follow and a easy enough tool that it's not overwhelming. You don't need to know Python or some fancy software to look at and analyze the data. So that's kind of where we're coming from. And specifically, kind of how can we help as a small company with the mission of America Makes, which is to really broaden understanding of the additive manufacturing world, specifically in the US, and to help companies in the membership base really accelerate and do the best they can with the technology. So we think of it as kind of a hierarchy. We've got a lot of different ways that data is being leveraged in the industry. So you've got a part manufacturer who's going to be kind of developing some of that information, doing builds on a day-to-day basis, and kind of looking at kind of what's in the literature, whether it's something like an MMPDS, technical data sheets from the OEMs, or in the case of America Makes, or some of the other standards organizations, some of the standard data sets that they have. So what we think about it is kind of a push and a pull. So I, as a kind of user of additive manufacturing technology, let's just say like, hey, I got my EOS M400, I'm building titanium or aluminum or whatever the metal of the day is, and we're just starting out. We need to understand kind of what are our design allowables, what are our material allowables, what are we going to get from a standpoint of mechanical properties. And so we start to build our own parts. We qualify that machine, we qualify our process, but it'd be great if we can see kind of how does this compare to other people. And so oftentimes that comparison is quite difficult because you don't always have the right parameters that make comparing two data sets consistent. So if I'm doing some builds and all my layers are at 40 microns and I'm going to compare to a data set that's 30 microns or 50 microns, that may not be exact apples to apples. So at least knowing that is something that people want to know, certainly in the industry. On the flip side is ultimately, if you're certainly in a regulated industry, or even if you're doing internal regulation, you have that AM data reviewer, whether it's a quality organization, regulatory, the FAA, FDA, either customer requirements, that ultimately you need to show that you can do something repeatedly and in a consistent way to maximize safety, maximize kind of revenue for the business. So Trace kind of fits in both of those kind of interfaces here, is kind of being able to translate data both from the part manufacturer and compare it to kind of data sources as well as data reviewers. And so we got here by kind of looking at the market. We have a pretty kind of deep team based on kind of the work that we're doing, but there are other kind of areas in the space that are doing this. And so what I wanted to talk about specifically is like what we done for America Makes, and over the last, I would say, 2 years since that first rapid innovation call, which I'll dive deeper in a second into, was helping to think through how you might solve some of these high level issues with data management, with data sharing. And so we've been on 4 projects to date, really starting to learn some of the ins and outs of data management when it comes to different projects, different technologies, and how, from a best practices kind of approach, can we make that ability to, one, simply collect data in an organized way and then share it to America Makes members who may not have been intimately involved in a given project. So that's kind of our fundamental mission that we're trying to do in supporting America Makes projects and working with the team to think through some of those challenges. And they've been tremendous partners as we've grown up in our kind of business and helped to develop our technology. So for those who are listening and our members, there's some open project calls now on the website. We've been involved in a number of those. I think it's a great experience. I would highly recommend teaming up with folks to address some of those industry-wide challenges. And if you have any questions or experience on that, I'm happy to share my insight. And certainly if people are looking to team up on projects, we're happy to do so as well. So the first project we did, which I'll go through in a second, was a rapid innovation call, looking at kind of conceptually, how do we make a sortable material database for America Makes information and data? Second one was looking at developing a data set for a novel technology called ultrasonic additive manufacturing. So a technology pioneered by Fabrasonic. So how do we develop a kind of pedigree data set or an organized data set for a given technology, and then how do we translate that? So that was kind of our second one. We were kind of cost share partners for a recent project on metal lattice design with the Ohio State CME. They were looking at lattice design and testing, and so we helped kind of with some conceptual thoughts of the data management piece, and we're also looking at a future project as well. So for what the challenges in America Makes, I think I'll start with that in terms of why do we even need a data management tool, and what's the issue here? So if you're a member and if you have kind of access to kind of your user's website or kind of the principal's website to get into the America Makes platform called the Digital Storefront. So the Digital Storefront is a kind of almost a train station in some ways that kind of connects all of the various digital assets that have been generated by America Makes projects and America Makes partners. And so right now, if you log in, it's with your username, you can kind of see a chart of some of the various projects that have been done over the last 10 years. There's been a lot of them, and highly encourage you to go check it out. But one of the challenges is that it's a little bit tricky to navigate effectively and time efficiently. You kind of have to know what you're looking for versus being able to just browse and check out types of data. And more specifically, as you get in more to the weeds of the problem, every time you do a new project, whether that's with metals or polymers, whatever it is, it's kind of up to the project team in collaboration with their program manager from America Makes to decide what data is relevant, what is going to be the focus. And there's kind of a need to have a baseline level of information so that if you do a bunch of tests on titanium lattices, you may not need to record, or it may be unique to record some of the lattice mechanical data. But what you would want to say, okay, tell me what machine, what material composition was this done with, what were the parameters of the machine, so that if you wanted to repeat that, or if you want to just kind of gain some insight to a similar machine and say, hey, I'm using an EOS M290. I keep going to EOS, but there's many other, just saying, an SLM system for the day, that you're able to kind of track and trace that information. And so the other piece of it too is a big piece of feedback we got from users as we started this project was, hey, this information is great. We find it useful, but we would love if it could be in a format that is easy for us to download or export, so we can use our own data analysis tools or machine learning tools, whatever it may be, and kind of put it in our ecosystem. And so that was a big piece of feedback. And one of the challenges right now, and just in terms of how projects are kind of put up in the digital storefront is usually it's a final report. There's maybe some Excel spreadsheets or PowerPoints with some data in it, but it's a little bit challenging to kind of keep that all in one place. And so what would be great, and kind of what the focus of our project call was, to look at, okay, how can we enhance the workflow of all this great research that's going on within the community and make some kind of consistent data management decisions and put it into a repository that serves some basic functions. Maybe you're not going to do all the analysis in kind of the America Makes or TraceAM platform, but at least gives you a tool to say, see it and organize it and analyze it eventually. So that's kind of the topic of what we're looking at. So it was a 3-month effort. We kind of partnered with a great team to get a series of perspectives. Deloitte was on the project kind of from a broad survey of all membership. They had done a lot of work with around, I think it's called AMCPR, around kind of COVID, and saw some of the connections and challenges around kind of transferring data packages. Senval, who many of you know, is a New York-based company that specializes in kind of databases and machine learning for additive. So Annie and Zach were great in kind of giving us a lot of perspective on their efforts. Northrop Grumman from an end user perspective, and DoD, as well as EOS, was on the project from an OEM standpoint. So we want to kind of hear from all the different stakeholders and assess, like, okay, what's going to work? How are we going to manage this and interact with it? So this 3-month kind of sprint for us was to see how we could adapt some of the work that we had done to show that what you could do with our software. And so we got a lot of learnings from it. It was great just to have firsthand experience and kind of talking with the teams that we've been on about data management. It's one of those things that often is kind of an afterthought. It's not sexy, it's boring, especially the organization of it. And everyone's always excited about, okay, what are the outcomes of it? But but just organizing and I kind of compare it to the plumbing of additive or the plumbing of a facility, to understand how thinking through what are some of the challenges, what are some of the things you want to collect when you're doing the build or the post processing up front. It always makes it a lot easier. We had a lot of understanding of what it's like to work with project teams and what you could do to make some of this workflow more smooth. Given the wide breadth of projects that America Makes does, it's not just laser powder bed fusion, it's DED. There's some new technologies. We did that project with Fabrasonic, which is kind of a novel tool that doesn't line up to some of the standards. So it's a diverse challenge, but what can you make consistent so that people down the road can leverage some of this data that is being done. And then the last piece is, we're not doing this in a vacuum. There's a lot of great efforts to standardize some of how you track and model data. One that we're involved in, and I encourage anyone who's interested can get involved in, called the NIST Common Data Model Consortium. There's probably 20 to 30 people on that across industries that are trying to standardize how you even label things like, is it a build or is it a job? So it's important because if you go to search for builds, it might not come up if you label it as jobs. So something like that. So there are efforts going behind the scenes to eventually make this something like an industry standard, ASTM, SAE type of standard. And so the way we think about this kind of from a tactical level, and I'll show a demo I've got plenty of time for that too, is that we think of kind of a hierarchy of levels within additive manufacturing data management. And so at the highest level, you have kind of either your project or customer information. So that's easy stuff to search, like, okay, what was your project name? Who was the investigator, organizations, kind of completion dates, things like that. So I think of that as like if you're in a library that's like the book name and the author name. So it says kind of the summary of the project, kind of the build level information. That's kind of the next layer down. That's your file and design information, your feedstock, your process details, kind of post-process inspection. Like we have a library analogy. That's you found your book. Now you want to open up your book and you see the chapters, right? And a lot of those chapters, for what we purposely tried to do is think about it as what's standard across every different technology modality in the industry, right? If it's 3D printing, you have some file and design information. You got to start with a 3D model, and there's information around that. You got to have a material. You got to have a process and process parameters on the machine to do that. Usually there's some post-processing and then inspection, some sort of testing that's involved. So those are consistent, whether you're doing SLA or FDM or polymer laser bed, SLS, whatever it is. So those are the chapters. And then we get into kind of the meat and potatoes as kind of the part information. And so those are the process parameters, the test results for an individual component, the post-processing or heat treatment for an individual component. So that's kind of like that's the story. That's like you're in a chapter, you see kind of what are the details of that specific build or that specific job. And so that's kind of the way we think about it. So kind of the title and author, kind of the book level, chapter level, and then kind of the meat and the actual words and sentences within that is how we think about it. And that's something we found over time has been easy to convey to people across the industry. So one thing I would encourage you all to think about, and many of you probably have thought about this before, is it's not just, you don't have, what we're trying to do is make something that's not just for engineers and operators of the equipment. We want to be able to kind of enable people to make decisions. I think that's one of the kind of things that we've observed in the industry as a shortcoming in some ways. A lot of manufacturers, believe it or not, are risk averse. They've taken a leap to bring in additive in some cases as a new business model, but there are still challenges in convincing their boss or the regulatory agencies that this is a good process. And one of the things that people tend to get stuck on is say, oh, we don't have enough information, and go back and do more testing. That's an easy crutch to rely on if you don't have your data well organized and can't tell a story about it. And so what we want to be able to help people with is to really just make a decision, make a call and say, hey, like, our material's not up to speed, or this process isn't what we thought it was. We need to go back to the drawing board, or just give people the ability to make a decision. Because I think ultimately, kind of in real life too, that's something that really holds people back, is people being not able to make a decision or come to a decision, and kind of just being stuck and just saying, hey, we need more, like put it off for another day, say we need more testing, or we don't have enough data, or something like that. So really what our goal of our company is to help organize data so you can make a decision. So what we wanted to think about in this case is, okay, how do we scale this to the next level ultimately, right? So we did some proof of concepts with America Makes. We're in discussions with the team of like, how do we kind of take this to a next level, or what do we still need to do to make this tool of valuable use for the organization? One is we learned that you need a really easy workflow that can be adapted in a variety of projects, as I've talked about. Even business logic that makes sense. That's things like, how do you log on? Who gets access to it? Do you go through the America Makes page? Do you go through a different page? Who can edit data? Who can download data? That needs to be super clear. Otherwise, people aren't going to use it. And then I think the other piece that we really learned is having crystal clear objectives and steps for data management project teams as they're coming into new projects to make it a little bit easier for them to think about this at an early stage. So, and that's kind of one of the things I wanted to harp on. But what I wanted to do was actually, before I end there, is actually go through a demo of it. So let me, excuse me. And feel free to ask questions. I don't know if I can see, I'm sure I can see the chat as we go, but if there are questions, ask away. And I'll do my best to kind of keep track of those. What I wanted to do now is kind of quickly show you a couple of things. One is, how does this typically work in practice, and what are we doing? So what I want to show you here is, this is a kind of going through a sample of our work that we did with Fabrasonic recently. For kind of the high level objective was, hey, this Fabrasonic ultrasonic additive manufacturing technology is really cool. It's got some awesome applications, potentially in aerospace and electronics, but there's not a lot of data on it. Certainly not a lot of public data that people can compare and get a sense to have like a reference. And so what the project aimed to do was fund some testing so that we could get kind of a standard data set, do 10 or 12 builds, get some data from a standard material, organize it, and publish it for the America Makes community. So then people have that as a reference. Also, new users, government users can quickly look at that information and say, hey, like, this could be a really awesome application for our new component on our drone or something like that. And so the idea was, that was kind of the overarching idea. And then where we fit in was, okay, this is kind of a new process that's doesn't fit exactly into the bucket of laser powder bed fusion, because there's no powder, there's no laser. It's you're kind of welding sheets together. It's a little bit like sheet lamination. So there's some different parameters in there. And this is kind of that standard spreadsheet that everyone has. If you're doing a lot of builds, you've got kind of your build outline, kind of 1 to 12, what material, your kind of material level details, your sheet level details. In this case, that's kind of what's being welded together, how it was extracted, your post-processing. And so you've got all of that alongside your parameters of the machine. And so nice, looks organized here. They did a great job in doing that. But how do we make that a little bit more accessible to and use this as a demonstration for Trace? And so that's kind of the context. So that's where I want you to get your head at for this. And so this is a kind of a screenshot of the Trace process, or the Trace workflow. And so the way we'll kind of run through it is, you log in, you see projects, data explorer, and documentation. I'll talk through each of those, but I'm gonna click on projects, because again, that's the highest level. That's where you're kind of looking in the library at the authors and subject of the books. And so we've got some example kind of data sets in here, and we'll focus on the Fabrasonic one specifically. But the way we started this project is really with a design of a data template, a data model template. And so with this, we had a lot of conversations with the Fabrasonic team and the Ohio State team who's partnered on this, to say, okay, what are the critical parameters, critical things that we need to track every build and every part? And they were the ones who made the machine, so they've had the most experience. And so we were able to kind of work with them to say, okay, at the project level, we need the project name, lead investigator, kind of boring stuff. But what Trace allows is for the production of kind of custom data templates. And so as you get into something like material feedstock, this is kind of unique because there's not a powder, there's not a filament, there's two different materials that you're welding together. So we needed kind of information for the base plate itself and then the ribbon or the material that was going on top of that. And so we went through and kind of did that extraction from the Excel spreadsheet into Trace, and kind of made a data repository. So or a data input kind of step-by-step process. So the way I kind of make this easier to understand is it's kind of like you're making a survey, right? You're asking people kind of every build, all these different questions. And so what we wanted to do is kind of what's that build look like, or what's that survey look like for each build. So you say, hey, we want to track the base plate material. So we write base plate material. And then is it a paragraph? Is it a multiple choice? Is it a checkbox? Is it something else? And so you can add and subtract questions if you wanted. You go through that each step of the process. So your machine, the actual process details. So you have your machine manufacturer ID, some of the specific machine settings in there. And so the reason we're doing this is because it was a unique process. I think there's always a balance in this of you want to make sure that people can customize their data model, but you don't want it so custom that you can't compare it at the end of the day. And so we've, for our commercial solution, we've developed some kind of standard templates that people can use if they're doing kind of standard technologies like FDM or DMLS. And we do that based on certainly our work with the Common Data Model Working Group, some of the ASTM standards and SAE standards that are out there and available. So I've admittedly spent more time than I care to admit reading a lot of those standards and kind of deep diving into them so that you don't have to. But yeah, so the first step is, okay, let's make our data model. Let's make a template for it. Then you can, I'm not going to create you would then create a new project. You can create builds on that project, but we've done all these builds, so I'm just going to go through it. So here's some kind of project level information. You've got your project name, who's in lead investigator, all that fun stuff. And then here are actually the project details. So we've got a number of the builds inputted in here, kind of say 1467-002 and 01. So you can click on each of those and then go through and start to see the story, what's in those chapters. So you've got all the build parts and the ID numbers where they're located on the build itself. You can look at the material feedstock information for each of those specific builds. And that goes all the way down to the foil and the sheet width, and just essentially taking all that you had in your Excel spreadsheet, kind of putting it in an organized database. You get into the process details. If you wanted to, you could edit your part parameters. In this case, we weren't doing that to a great degree, but say you were doing a laser powder bed fusion build and you had 34 parts and each of those parts had slightly different laser parameters, you could easily ingest that information. Post-process information, and then all your inspection data. So you can kind of show, we did some tensile reports on this, and you could see all the data there. And so that's kind of the proof of concept that we did with this. As we got further along, we wanted to say, hey, can we demonstrate some of this or analyze some of this data and show it in different ways? So we've got kind of a pretty grungy looking analysis tool, but it kind of gets the job done. So if you've ever done Excel work, this is kind of like a pivot table where you can kind of pull in kind of data sets that are in the database, and kind of show what the data is. You can do some average, some simple statistics on it based on what's in there. This is kind of just dummy information. You'd probably never say compare your machine manufacturer or your feedstock manufacturer by your process operator, but they kind of get the idea, and you can make tables or other types of simple graphics that you could then export if you wanted. one thing that I forgot to mention on this as well. I'm going to go back to the project data. So for this, if you remember, one of the big pieces of feedback was, okay, how do we, if someone wanted this data, how do they extract it? And so we put a kind of a nifty little tool in here called export that allows you to do kind of one click and export that information from that project. And so what it would do is you download a zip file, you have an Excel spreadsheet in there that's easy to put into some sort of machine learning or other analysis tool. And the idea is if you had 12 builds, you'd have 12 different tabs, which each of the fields and the data's in that specific field. So yeah, and then the last piece I'll kind of demonstrate here, and I'll go back to the slide deck, is kind of some non-standard additive data that we heard from users that would be nice to include. So this is information that is not numerical necessarily, more for like reference in the background. And so if you wanted to use Trace to say, hey, either in an organization or within a consortium like America Makes, maybe you want to put in some standards, or you could put in the ANSI America Makes standards roadmap. You could upload that as a PDF in here, so that users could log in and see that. You could add material safety data sheets. Again, something that you probably wouldn't have and things that you would compare, but nice to have in one place. Same with operating procedures. Maybe there are specific nuances to operating the fabriconic, ultrasonic additive manufacturing process that you need to know to make this data make sense. And so this is a repository where you can kind of keep that information so that's there, it's able to share, and you can kind of keep track of some of those nuances that may not be obvious from just looking at the data. That's something that we heard a lot of feedback on. I kind of think about it as like the stuff you learn at AMUG when you're having a beer with the group of users, is like some of that nuanced stuff that you're not going to necessarily pick up. It's not obvious, but you still want a place to document it. So so that's kind of how the TraceAM system works, and how we've been working with America Makes on doing a lot of that work. I'll kind of end with just a couple of slides on some other work that we're doing, and obviously have some room for questions at the end if there are some. So as Jason mentioned, let me make this a little bit bigger. We also work closely with America Makes to kind of help with giving an on-ramp to folks in different areas of the country, specifically starting with Chicago, just underserved areas that may not have obvious on-ramps to advanced manufacturing and all the job opportunities that are available. So we've been doing a teaching course, kind of voluntary, where we kind of use America Makes curriculum. We go on factory tours of America Makes members like Impossible Objects and Renishaw, and show people kind of what some of the possibilities are. We just started our second cohort. If you are interested in getting involved, we're always looking for mentors who are willing to share their career story with the group. And it's this is a younger group that we took around, but currently the participants are kind of 21 to 50 years old, wide range of backgrounds, like a union carpenter. We have folks that work in food service, just people that are passionate about working with their hands, like they show up on time, and we're looking to help support them in their career journey with an additive. So if you are interested in helping with that, it's all voluntary. We've been kind of excited about the mission for the last couple of years, so let me know. And then the other thing that we try and do for the industry is share different stories about the industry, what's going on. We have a podcast called 3 Degrees Discussions. I think some of the folks that I saw on the call have been guests. We have a number of listeners. I think we are up to, this is old, so I think we're up to 14,000 listeners. I'm about to release episode 100. We do 1 episode a week. So if you're, again, interested in listening, feel free, and really as a educational platform to share stories around the industry, but always looking for new guests, and we do this once a week. So if you're ever interested in sharing your story or talk about what you're doing, happy to have you on. And so that's we got about 10 minutes left. I'll start to take a look at the questions up there if there are some. But all right, we did see some. But yeah, the other thing that I'll mention too, my email is down here. It's mike@3degreescompany.com. I'm based in Chicago, but I will be at MMX all next week, kind of Tuesday evening onward. So feel free to reach out and meet me in person or drop me a note. Let's see. So I'm going to pull up some questions here. All right. So one is from Nadine. I probably butchered that, but do you integrate with Eiger Fleet or GrabCAD? Not for the moment. So that's a great question. So we've we kind of think of ourselves as in a slightly different kind of workflow than like I would say a like a factory management system. And so what we can do is typically we don't want to store like big CAD files or anything like that. We'll usually do a link to kind of where those reside locally. And so our approach has been to kind of keep ourselves separate from that. Not to say that we're not doing integrations. Being a small company, we have to kind of we've observed what some of the challenges are in doing a lot of different integrations, but we are interfaced with organizations like Renishaw. We have an API that talks to their systems and pulls data from their machine directly, which is another question we often get. And so that's sometimes can be some bigger data sets, but specifically to that question, no, we do not interface with those two specific softwares, GrabCAD or Eiger Fleet. So another one from Nick. Could I comment on how Trace encourages users to use common terminology, definitions, so that different inputters aren't using different terms to describe the same parameters? Excellent question. Yeah, we're doing our best to do that. So we're part of the NIST Common Data Model Working Group, which is kind of a group of people trying to come up with some of those common terms. And so we try and do that specifically at the kind of data model templating phase. We've got some general tools that we use to or general formats that we use so that you're not calling a job a build and then you can't compare it. But often that's like it's not always automated. It sometimes takes some conversations with the team to discuss and get into the nuance and the weeds. So we realize that's a issue. We're trying to do our best to follow what standards there are and make some standards as we go. But certainly within America Makes, we've tried to kind of keep perspective of kind of what are some of the best practices in terms of data labeling, data tagging, is what we call it. The other piece is we want to be able to make sure that the average user can understand what you say when you mean material lot or something of that kind. So we want to be consistent, but also accessible. Another one from Nick. How large of data set can we handle? That's a good question. We haven't. We're a cloud-based system. It runs on Amazon web server. We're starting to work with we haven't done anything like taking a CT scan and uploading it, or more specifically, what would be probably more relevant for us is like slice data, or like taking an image of every slice of a build. We're looking at doing that with the Renishaw system because we can port into like a snapshot of a rebuild. But I think our argument against doing something like that is it's one of those, and this is me going on my soapbox for a second, is like until you can show me like that information is beneficial in having, I think we have to think strongly about how effectively can we put it into this system. And so what I mean more specifically about that is um, there's always going to be a balance between what data do you need to make an effective decision. Maybe you're just looking at tensile information. Maybe you're looking at a go no go situation, like, hey, was our oxygen content in the right window for us to ship this part to the customer? Like, that's great. I think that's the type of decision we're focused on. I think there's also an argument that I wrestle with myself, being a PhD materials engineer, is like, hey, like having more data is never a bad thing, especially if you want to go to look historically at things. And so we haven't done super huge like data sets where it's like a gigabit of scan data or something like that, but not to say that we couldn't. We're just still working on the tools to make sure that we can connect that information, whether it's graphical information, image information, to the data set. So something we're wrestling with and trying to prioritize. Let's see. What about Hexagon's ICME for materials management and simulation? Yeah, so we're Hexagon's actually a partner on one of the projects we're working on. There's a lot of different tools that do that kind of pull in additive manufacturing data, like the Senval database, and so we're trying to kind of work within the ecosystem and be a partner and share ideas for different users groups, because I think what we've realized quickly is that no one additive user is the same even within the broad community. Aerospace acts differently than medical, than heavy industry, than defense, and so we want to kind of be good stewards of the overall industry, because we strongly believe in kind of bringing American manufacturing back here and enabling that to kind of get past the data management piece and get into producing good parts and making decisions that help your business. And so that's kind of our effort, and anyone that we can work with to help do that and share lessons. We're very open about what we've learned on this and why we like to do these webinars with Jason and the America Makes team to help kind of move the industry forward.
All right. Thanks, Mike. So I don't know if you could see, but there's a couple of questions in the chat if you want to take a look and answer those.
All right. Let's see. I think I've seen all the ones I've seen the ones in the Q&A. I think those were the.
You want me to go ahead and
are there
read
some
them for
others?
you?
Yeah. I haven't seen.
Okay, so the first one is, how does TraceAM compare to established data management platforms like Tableau?
Yeah, again, kind of similar answers. Like, we're very specific to additive manufacturing and kind of the process workflow within the specific machine set. So that's where we kind of grew up, and really we came at this from our experience just talking to users across the industry.
All right, thank you. And let's see, a follow-up. Does TraceAM imagine different management products for different AM process types?
So the way we think about that is we just think about it as different data templates, and so it all be stored in TraceAM. You wouldn't need multiple deployments. You would just have a FDM deployment or a FDM trace template, a powder bed fusion trace template, things like that.
Thank you very much. And I think I have one more here. So what are the challenges of inserting this software tool between manufacturers and a regulatory authority?
Yeah, so great question. So I think data security is always a question that comes up. We didn't talk about it much because I think it's a whole different can of worms. That's always one thing. I think as the industry matures, I think our goal is to kind of help in that interaction, so that either you don't have to do as much testing, or you have benchmarks that you can compare different data sets, or a regulatory could say, hey, like, we know that historically titanium for medical implants kind of fall in these categories for fatigue and for tensile properties. And so having an easy way to sort through that data is something that is hopefully would be good for everybody, whether you can use a tool like TraceAM to just share that data directly. We'd love if that was the case, or would be willing to talk about that. But I think it's still, we've seen it as still pretty early days, but certainly something where we'd like to go to, whether it's with a standard organization, if we're working with some of those right now to be an interface, or someone like MMPDS where they kind of keep some of that data repository. So there's a lot of different efforts. ASTM has some efforts going on that that I want to kind of be in that space. And I think it's needed for the entire industry.
All right, thanks, Mike. There was a second part of that question. I think I'm gonna send it to you offline, and maybe you can follow up.
Yeah.
All right.
Absolutely.
So, all right, thanks, Mike. 1 second here.
And feel free to email me if you have any questions, or if you see me next week, say hi. So.
All right, sounds good. Yeah, we hope to see everybody at MMX. Come talk to us about team building for open pro. Well, don't talk to us, but talk to our other members about team building for the open project call and topics for the Wrap Innovation call. So that's going to wrap up today's TRX webinar series. I'd like to once again thank Mike. If you do have further questions for Mike, please reach out to him directly, like he said, at mike@3degrees.com. And just a comment, Mike, this brings me full circle, because my first TRX webinar was actually your TRX webinar I did back in, I think, 19. So this was a great webinar for me to do, and I thank you very much. But there will be a post-webinar survey going out to all those who participated. We do really appreciate the time you take to provide America Makes feedback so that we may continue to improve and strengthen the additive community. And as a reminder, if you think that your organization would be interested in sharing on the TRX webinar series, please fill out the form that follows the presentation, or reach out to me, Jason Thomas, at jason.thomas@ncdmm.org. Thank you very much, and have everyone have a great day.